All right, class. So yesterday we covered matter, the introductory information we talked about. Today, as a warm-up to get us thinking about what we're going to discuss, I want you to give me 10 examples on your paper of matter in this classroom. It needs to be done silently. You only have 45 seconds, and all you have to do is listen. Another 15 seconds if you're working. Make sure you review your answers. All right. Any volunteers about what in this room classified as matter? Yes, Tom.
Concrete.
Concrete. Why?
It has molecules. It has atoms.
Okay. Robin. A table. A table. Excellent. Anybody list any solids? I'm sorry. Liquids?
Water.
Water. Okay. What about gases in the room? Air. Air is a gas. What do you expel from your body?
Carbon dioxide.
Okay, also gas in the room. Okay, excellent. So, if you could sum up matter in a few simplified words, what would you say matter is? Everything. Excellent. If we were going to put it in scientific terms, Tom, I'm going to pick on you. What would you say?
Anything with mass and anything with mass.
Anything with mass.
Go
Good.
with that.
Excellent. Very good. Now remember, we talked about yesterday, matter is made up of elements, and elements are made up of atoms. So going off of that for today, we're going to talk about states of matter and how matter can transform. So if we take ice, for example, what form of matter is that?
Solid.
It's a solid. Excellent. Okay, and Robin, as it gets warmer outside, what happens to the ice? None. Okay. And then it's really hot. It's summer. It's just been a horrific thunderstorm, and there's puddles on the ground of water. Now it's getting really hot outside. What happens, Tom?
It turns into steam
Why?
because it's getting heated up and it's basically the molecules get filled with it.
Okay.
Changes state.
Excellent. Change of state. Very good. And does anybody know what the element is for water? What is it? H2O. Okay, great. So that is one particular element that has 3 states of matter, correct? Excellent. Okay, now I want you to take notes for this next part. We're going to take some simple, quick bullet style notes, and then we're going to get up and do an actual exercise to demonstrate the different types of matter that are in our environment. Okay? All right, so solids. First thing. We're going to use some examples to use this. Okay. Actually, you know what? Maybe this one's better. Is this soft or hard?
Hard.
Hard. Okay, so solid is usually hard. Does this have a definite shape?
Yes.
What is it?
Okay.
Pen. Okay, excellent. So, solids usually are very hard, and they have a definite shape. You can go ahead and put down pen as our example. Now, when we look at solids from a scientific point of view, they are atoms or molecules that are very close together, and they move very slowly, which is what forms the shape and makes them so concrete in existence. So we're going to stand up. I want you to come over here. We're going to do a little exercise. Now, you don't have to go home and have a pizza party with this person. You just have to do the exercise, so come nice and close. I want you all to link arms, so you're really close. Now, this is a molecule or an atom for a solid because you're nice and close together. You're stuck to each other. Now, I want you together as a team move from that little piece of paper to this little piece of paper. Now, you have to do it slowly so that nobody falls down or gets injured. When you're ready. Okay, excellent. Very good. So, you can separate now. If you all are atoms of a solid, what did you have to do to get over here? Could you space out, or did you have to stay close together?
Stay close together.
Why? What would happen if you
You sort of change state.
did? Okay, excellent. Very good. How did you move? Quickly or slowly?
Slowly.
Slowly. Very good. Excellent. All right, have a seat. Good job. So we just demonstrated with our own bodies how an atom would move if it were a solid. Okay, next one, liquid. We're going to use the water bottle. We look at this water bottle, not the actual water bottle itself, but the liquid inside. If liquid is just in a container, what shape does it take on?
Whatever the shape of the container.
Okay, so in this particular instance, it's a water bottle. What about a bathtub?
Same thing, whatever.
Whatever shape. Okay, excellent. So it takes the shape of its container. And like the solids, atoms in a liquid are close together, but they're not quite as close together because it's not hard. Liquids are not hard, correct? Okay, so we've got this liquid in a container where the atoms are a little bit more spaced out. However, they're still linked together. So for your liquid, make sure you put takes on shape of container. And then atoms are spaced out. You ready? Excellent. Okay. 2 volunteers again. Robin and Tom. Thank you. Come on forward. Now again, you're not going home to have a pizza party. You're just doing demonstrations, so I want you two to hold hands. I know. Hold their hands. So you're a little bit more spaced out than before. You're not linking arms. You're still together though. So now I want you again to move from this spot over there. And we're going to demonstrate how atoms of liquid for the rest of the class work together. Go for it. Okay. Was it easier this time to move? Why? More space. Okay. So you're not so close together. And did you move more quickly than before or slower or at the same rate?
More quickly.
More quickly. Why do you think you did that?
The heat made us more excited.
Okay, I like that. Excellent. Have a seat. Very good. So now we've done 2 demonstrations. We've got the solids where we have the tight packed atoms. Then we've got the liquids where they're spaced out a little bit more. And now we're going to talk about gases. Okay, so write gases down. Rob, do gases have a shape?
No.
How do you know?
Well, if it's in a cylinder, it couldn't go out of there, so it could take the shape of a cylinder.
Okay. When we think about just the environment in general, is air confined to a particular shape?
No.
No. Okay. So gases are shapeless. You guys can go ahead and write that down. And when we think of the environment or the world, and you think of just air as an example, how much space does air have to move around?
Tons.
Tons. Could you count it? All the space? Is there a particular height that the sky goes to that the air's got to get to?
Yes.
There is. So it's got a limit.